into something over 4. 20 over 4 is the same thing as 5. Okay? All right. Is everybody with me up to this point? This is just working with fractions, getting a common denominator and putting it together. Okay, well now what we're going to do is take the square root of both sides, which means I have plus or minus. All right, now look at the fraction. The radical is over both the top and the bottom. Can you reduce the square root of 29? No. Can you reduce the square root of 4? Yes.
Oh, so you can still change it? I thought if you took the square, you gotta take it up.
They're both under there. So it's like separating them, okay? And so now when I subtract 3 halves from both sides, I want to combine that into a single fraction. Well, it's okay because they both have a denominator of 2. So all I have to do is put the numerators together, which I can't, but I can do this. Okay? So your final answer needs to be as a single fraction.
Okay, so if on, like, if both, like, 29 fourths, or what was it? Start off with? 29 fourths is under the radical. Like, if just one half of, like, the bottom half is...
It's the same thing as this. And so you can take each one individually and reduce it.
What if the top one's...
If the top one can be reduced, reduce that one too. Okay, yes.
What if 29 over 4 wouldn't have been able to reduce the denominator too?
Then you would have to go back to our rationalizing the denominator and getting the radical out from under the denominator. Okay, but we're not going to deal with that today. All right? Our problems tonight, you're not going to have to worry about that. That's for the future. Okay? Aaron, what goes in parentheses? Okay. Multiply 9 times 4. What's 9 times 4? What's 36 over 4? Same thing. Okay?
Why'd you put x squared minus?
Because I'm retarded. I didn't mean to. Okay. Here, I'm going to square first. That gives me 49 fourths, right? And now I need to take negative 9 and turn it into something over 4, which would be negative 36 over 4. This should not be an issue. This part should be easy. All right, well, what's negative 36 plus 49?
15.
So I have 13 fourths equals this. All right? Now what you're going to see on all the problems tonight, I think, is that this is all going to work out when you bring the other one over, and it's just they're going to have the same denominator. Because when I take the square root of both sides here, I have x minus 7 halves equals plus or minus. Can you reduce the square root of 13? No. But can you reduce the square root of 4?
Yes.
Yes. And so when I add 7 over 2, they're both over 2. So it's 7 plus or minus the square root of 13, and they're both over 2.
What if it had been a plus 7 halves?
Then you would have subtracted 7 halves, and this would be negative 7 plus or minus.
If it doesn't matter which one's negative.
Doesn't matter.
You have to put the bracket thing in.
Yes, I forgot to. Sorry. I'm looking at the clock and worrying because we only have 5 minutes left. All right. If a trinomial is not a perfect square trinomial, like the ones we did yesterday where we had 36x squared plus something plus 9. And we said the first and last were both perfect squares. If that's not the case, the x squared term cannot have a number in front of it. It has to be 1. So, when we look at this one right here, this is where fractions are really going to start hammering you if you're not good with fractions. I have a coefficient in front of x squared. It's not a perfect square. I cannot factor that trinomial. So, I've got to make the coefficient of x squared 1. How am I going to do that? I'm going to divide everything by 2. And in the process, I'm going to go ahead and set it up. Okay, so when I divide this by 2, I have x squared. I divide this by 2, I have negative 3 halves x. I bring 3 to the other side and divide by 2, which gives me positive 3 halves. And I've got to figure out what to add to both sides to complete the square.
Wait, you don't have to divide that number that you're going to get by 2?
Nope. I'm creating this number based off what I just did. Okay? I'm going to create this number based on my result here. I don't have to then divide it by 2. But I divide everything that was originally in the equation by 2. Okay, now we said with fractions, we're not actually going to divide by 2. We're going to multiply by 1/2. So what's 3 halves times 1/2? So 3/4 is what goes in here. Okay? All right, so I have x minus 3/4 squared is equal to, okay, now we have all kinds of fractions. Don't freak out. Do the same thing. Square 3/4. What is that? 9/16. All right, now I want to change 3 halves to something 16ths. 24/16. Because 2 goes into 16 8 times. So 3 times 8 gives me my 24. How do you change 3 halves into something over 16? Okay? 2 times 8, so 3 times 8. Right? Okay. Wait. Come see me at lunch. We need to move. 24 plus 9 is 33 16ths.
Teachers, please excuse the interruption. This announcement is regarding the mission team members. You're to go by Mr. Chambers' room sometime today to check your job assignment for the banquet, which is tomorrow night. Thank you.
All right, and then we just keep going. You take the square root of both sides. 33 does not reduce, but the square root of 16 is 4. You add 3/4 to both sides. They're both over 4. So it's 3 plus or minus the square root of 33 over 4. I want to get one more in before the bell rings. Okay? We have time.
Oh, so if it's already the other side, you leave it? Like, if there's already 4 on the other side, you don't change it?
Yeah, don't change it. You don't need to. Okay, we're going to divide everything by 2.